Right, so disproportionation reaction. All this is a redox reaction where one species is both oxidized and reduced. So we only have, it's like a decomposition. Okay, where we've started with something and from it, that one thing, we have two products. But it's a redox decomposition. And our example here is hydrogen peroxide. What do we need to remember about hydrogen peroxide? The oxygen has an oxidation number of -1. That's right. And because there are two of them, that gives us a total of -2. And our hydrogen is +1 as normal. But this is our special case, if you like, for oxygen where the oxidation number is not -2, it's -1. And it decomposes quite spectacularly sometimes into water and oxygen gas. And that's obviously a redox. Why is it obviously redox?
Well, the oxygen gas is just an element.
Yeah, because we formed an element and we know that our oxidation number of elements is 0. So we know just by looking at it, this particular one must be redox. Not all redox reactions involve elements, but that's just an easy way in for quite a few reactions. So what's happened to the oxygen part here? If I've gone from -1 to 0, I have to have lost an electron to become more positive. And so, Chelsea, what's that? Oxidation is loss.
I was even going through the ordering in my head.
Okay, so that must have been oxidized to oxygen. And we can also see, well, and in this case, it is the hydrogen peroxide is oxidized to oxygen. Okay, it's not just the oxygen, it's the whole species, remember? And then we look at the water. Well, this is not a special case for the oxygen. It has the oxidation number of -2. There's only one of them, and each of the hydrogens are +1. But in this case, the oxidation number of the oxygen has gone from -1 to -2, and so therefore it has become more negative, which means it's gained an electron, and that is the rig part, isn't it? Reduction is gain. So what we have here is reduction. And what we can say then is that the hydrogen peroxide is reduced to water. Okay, does that make sense? That we can see that this is redox, definitely redox, but because we only have the one species, it's given this special name of disproportionation. And there are a couple of these kinds of reactions. It's important that you start picking up and learning, remembering these words. So that's a word from Criterion 5 that you need to know and understand. Because maybe the question might say, is this a disproportionation reaction? And if you can't remember what that means, well then it's hard to answer, isn't it? So make sure that you squirrel that one away in your brains to come back later, especially much later at the end of the year when the content isn't so fresh. Okay, well, it's not a balanced reaction. Let's balance it then. We didn't need to balance it to determine whether it was a redox reaction or not, but certainly balanced equations are useful. So what would we need to do to balance it? 2.
Two in front of the H2O2.
And the H2O.
2 and a 2. Everyone happy with that? Yeah. Yeah, I reckon that's right. Very good. Thank you.